Hello, in this video we're going to be working on 2.5 extension, solving compound inequalities. So our first example here, this is an example of a compound inequality. Notice you've got solve 3y minus 5 is less than negative 8, or 2y minus 1 is greater than 5. So you have two simple inequalities combined together with an and or an or statement. In this case, it's an or statement to make a compound inequality. So if you've got an or statement, the nice thing about it is they've kind of already got it divided up into two separate problems for you. So for example, we have 3y minus 5 is less than negative 8. And over here we have 2y minus 1 is greater than 5. So our first step over here is just going to be to solve this inequality. So we're going to add 5 to both sides, which cancels this out, leaves us with 3y is less than negative 3. And then our last step to get y by itself is going to be to divide both sides by 3, which leaves us with y is less than negative 1. Now over to this example, we're going to add 1 to both sides to start off. So we get 2y is greater than 6, divide both sides by 2, and now we get y is greater than 3. The or that we started off with is going to come down in between here. So we have y is less than negative 1 or y is greater than 3. Make sure we follow the directions. It also asks us to graph this solution. So we're going to create a graph. And I'm going to start off with negative 1. I'm just going to count by ones. 0, 1, 2, 3. For this inequality over here, we have an open circle at negative 1. And our shading is going to be to the left because it's less than. And for this inequality over here, we have an open circle at 3. And our shading will be to the right. So our solutions to this compound inequality is y is all values that are less than negative 1, all values over here, or all values that are greater than 3. And notice we have open circles here, so those solutions do not include negative 1, and it does not include the number 3. Our next compound inequality example. So this is an and statement. This statement says that negative 2x plus 1 is greater than negative 3, and it is also less than or equal to 9. So notice in this and statement, we only have one expression here between kind of our two numbers, our two endpoints. So we're going to split this up into two separate inequalities. We're going to look at this as negative 3 is less than negative 2x plus 1. And we're going to look at it as negative 2x plus 1 is less than or equal to 9. So now we've taken that single compound inequality, we've split it up into two simple inequalities, and now we're going to solve. So we will subtract 1 from both sides. So we'll get negative 4 is less than negative 2x. We'll divide both sides by negative 2, and as you recall from prior lessons, anytime we divide or multiply both sides by negative, that is going to flip our sign around. So we get x here and 2 here. And then I'm going to leave that alone for right now. Over here, we're going to subtract 1 from both sides. So we get negative 2x is less than or equal to 8. Divide both sides by a negative 2. So we get x is greater than or equal to negative 4. So now when we go to graph this, you have to think about your number sense a little bit here. And oops, I can see that negative 4 is my smallest number, 2 is my largest number, so I'm going to start off at negative 4, and I'm going to count up by 2's. So x has to be less than 2, so I'm going to have an open circle at the 2, and less than means I'm going to be shading to the left. X is also greater than or equal to negative 4, so I'm going to have a closed circle to the negative 4, and I'm going to be shading to the right. So notice my compound inequality here, it's an and statement, they're shading in toward each other, so that's what the graph would look like. Now, I need to bring these two inequalities back together as one inequality. And what that's going to look like, your x value is going to go in the middle because it's in between these two numbers. X is greater than or equal to -4 and less than 2. So there's two examples of solving compound inequalities with an OR statement, and then with this example being an AND statement.